Hello, and the moment you've all been waiting for. We usually say there's 5, but we put these 2 as different things. Particles are in constant motion and in fast motion. Really, don't overthink this. The last one that I forgot to add for you, is often the one that you see first when you look at this simulation. We think of particles. Particles behave as, we say, small hard spheres, which means they bump into each other, they do not go through each other. This is kind of the same idea as you and your table. You are mostly empty space, your table is mostly empty space, however, you cannot go through your table, think like a ghost, because the outside particle on your atoms, your being, the electron, you've got a shield of electrons around you. The outside particle on your table's atoms are also electrons. Your electrons repel your table's electrons, and it's those 2 shields that are unable to move through each other. All right. So even though gas particles are really small, they also have essentially like electron shields around them. So we say they behave like small hard spheres, which just means they're real tiny and they bounce off of each other. They do not go through each other. So particles behave as small hard spheres. Right, so they repel each other is what we say. To create a chemical bond, you have to overcome that repulsion, but we'll get into that sometime. Yeah, cool. And your number 5, if you're on this page and you super want your number 5, go ahead and erase fast from number 1 and write particles are in fast motion as your number 5. That's fine. They don't stop, constant motion, and they're going really fast. Great. Yeah. I think I was going to tell you some about the atmosphere. We usually have great conversations about like the atmosphere and how gases behave within the atmosphere. And for example, here's the real question that you all want to know, even though you don't know this yet. But the back of this page should say atmosphere, which sometimes I'll kind of pull out of you at some point along the way. Atmosphere. So let's just do one question here. Why does helium float away? I always get that question. Sometimes you phrase this question as, why, when I have leftover party balloons after my party and why does helium make my voice all weird? It's actually the same question. Okay, and the answer to this great question, you always want to know the answer to, is right here, back on this. Okay, if you happen to have one of these handy, look around. Where is your helium, and what do you know about it? Helium is just a gas. It's a noble gas. It's over there. Something in that box is going to answer your question. That. Helium's tiny. It has 2 protons, total mass of about 4 AMU, grams per mole, whatever. Compare that to what most of your atmosphere is made of. Most of your atmosphere is nitrogen. Nitrogen is diatomic. It runs around as N2. It's got a mass of 28.02. Helium's just super small. The Earth, the mass of the Earth, the gravity of the Earth is not enough to hold the helium. That's just how that goes. So assuming your bigger, your gas giant planets, if you're into astronomy, And our solar system has some rocky planets and some gas giants, right? So our planet is a rocky planet. We have like a solid crust. There we go. I'm missing a word here. Right, there's like iron in the middle. I'm not going to go super deep into astronomy. We have a rocky planet. The rocky planets tend to be smaller and they have less mass, possibly ironically. But the mass of our Earth is only, like, the mass creates the gravity, right? Gravity is only strong enough to hold certain gases in our atmosphere. We can hold the nitrogen, we can hold the oxygen, which is also diatomic. It is 32 grams per mole. Things heavier than that, right? So like there are gases that are even heavier. Even carbon dioxide gets kind of weighty. 44 grams per mole. But something like helium, hydrogen. So Jupiter can hold these. If Jupiter was a little bit bigger, Jupiter could be another sun. And the sun is also made of hydrogen and helium. They're real big. They're like way bigger than Earth. So it takes a lot of mass to be a gas giant, right? Giant. So to hold on to things like gases, like hydrogen and helium, you have to be a really massive thing, like a massive planet, a giant planet, or a star. Neither of which Earth is. Earth is rocky, which we like because we can survive, but Earth does not have enough gravity to hold the helium. So when you let go of a helium balloon at your birthday party or whatever, and it goes up into the sky, it's gone. It is going to continue beyond the atmosphere into space. The balloon will pop away before then because the balloons that we drew on the other side of this page, like eventually the pressure of the atmosphere pushing in on the balloon is going to be real weak because gravity doesn't hold. Once you get to the kind of the edges of the atmosphere, there's not a whole lot of particles out there. So the helium inside the balloon is going to be creating more pressure on the inside of the balloon than there will be pressure on the outside of the balloon. The balloon's going to pop. The actual like rubber part of the balloon will fall back to Earth somewhere. But the helium that you had inside of that balloon will continue onward into space indefinitely because Earth's gravity is not strong enough to hold on to it. So why does helium make your voice weird? Same idea. We perceive small, fast sounds as high pitch. I do an entire unit on sound and physics, and we get into the same kind of stuff here. Faster vibrations you hear as higher pitch. Frequency is pitch? Yeah. Oh, yeah. I mean, right? Like when you speed up or slow down a video on YouTube and you put it at a faster speed, everybody's voice, you perceive their voices be higher because they're going faster. Same thing here. This lighter gas causes your vocal cords to vibrate faster. You perceive that as being a higher pitch. You take that same YouTube video, put it on 0.5 speed. Now everything sounds like slow and low. There's another gas that's also non-toxic in, small amounts that you're done with your Cheez Whiz or your creamer or whatever. There's a little bit of gas left that's carbon dioxide. Carbon dioxide is 44 grams per mole. That's more than the 28 grams per mole that's average in our atmosphere. CO2 is a heavier gas. When that travels through your vocal cords, it's heavier, it's slower. It creates this perception that the pitch of your voice is lower. Those are two burning questions that you sometimes ask along the way. I think I'm going to leave you there for this moment. We will come back and do more stuff later, but for now, we'll call that a wrap. See you soon.